Hello and welcome to this video lesson on disposing of polymers. What we're going to do in this video lesson is we're going to first of all look at polyalkenes, addition polymers, and the fact that they're chemically inert so that they are non-biodegradable is one feature we're going to remember. Then we're going to look at the condensation polymers, the polyesters and the polyamides. And they can be broken down by hydrolysis, i.e. adding a water molecule, and therefore are biodegradable. And we will appreciate the advantages and disadvantages of different methods of disposal of polymers, whether we burn them, whether we landfill them, whether we recycle them, that sort of thing. And lastly, we're going to appreciate the advantages and disadvantages of recycling. So, but before we get into biodegradability, let's just appreciate how widespread the use of plastics is. The synthetic polymers have so many advantages, they are incredibly widespread. Let's think about some of the advantages of the polymers, for example, the ones we see here. So, the advantages might be they are quite strong. In the case of this crate, no, not strong as metals obviously, but stronger than paper or cardboard, and yet still quite light. The crash helmet needs to be pretty strong as well. They can be, in the case of the Teflon layer on the frying pan, they can be very smooth or frictionless. This is particularly light. Let's see, right? You can make them very attractive colours. Thermally, they don't conduct heat. Which is an advantage for the paper cups, or the polystyrene cups rather. And they're also cheap. All these products are incredibly cheap. No, at least they have been cheap when the oil price has been low. If the oil price gets up to $100 again, as it did a couple of years ago, then obviously plastics become more expensive. And so, there we are. We have a bunch of synthetic polymers, so you can see their use is incredibly widespread. Because of all the advantages that they have, but now we're going to move on to the biodegradability of them, because some of these are biodegradable and some of these plastics are not biodegradable. And the biodegradability of a plastic depends upon the link between the monomers. And the link between the monomers can either be polar or it can be neutral or inert. And with condensation polymers it tends to be polar, and with addition polymers formed from alkenes, then the bonding between the repeating units tends to be inert. And polar bonding attracts nucleophiles like a water molecule, and if a water molecule can get into a polymer, it can break it down by hydrolyzing it. So we're going to have a look at that as well. So we're going to look at it by means of this table, and we're going to compare our addition polymers and our condensation polymers. So first of all, let's remind ourselves of some examples. So examples of addition polymers might be polyethylene, usually written like that, or spoken as polythene, and polystyrene, you might be familiar with that with your packaging. If you buy a laptop, for example, it often comes packaged in polystyrene that's been aerated. And examples of condensation polymers might be PET, which you would find in fizzy drinks bottles. Or you could, that's what carrier bags are made out of. And nylon, lots of different uses including clothes. That's a polyamide. Okay, so, and terylene that we came across before. And so there's a couple of examples. Let's now consider whether they are chemically inert. Well, then addition polymers, yes, they are chemically inert. The bond between the repeating units in addition polymers is a carbon-carbon bond, and so there's no polarity between those two carbon atoms. They both have the same charge, and so water molecules, for example, or other nucleophiles wouldn't be attracted to either of those two carbons because they're not positively charged. Whereas condensation polymers are not. They're not chemically inert. No, they are not chemically inert. If you remember back to the example of terylene, for example, our bond between our repeating units was this one. So this bond between the carbon and the oxygen, the single bond, was the bond between the repeating unit. And what you would find is that because oxygen is so electronegative, you would have small negative charges on the oxygens, leaving a small positive charge on the carbon. And so a water molecule, that might look like this, which has a lone pair of electrons, which would be delta negative, a little small negative, and you would get that attraction to the carbon atom, the positively charged carbon atom. And so that water molecule is going to attach itself to the carbon atom and do the opposite to the condensation process that formed the polymer in the first place. It's going to hydrolyze that in the process, breaking the bond between the two repeating units. Okay, so we're just going to consider why in words. We've sort of explained it there. So the bonds between the repeating units are not polar. So that's these bonds here. So these bonds here, the bonds are polar. And so they're susceptible to attack by a nucleophile such as water. So let's just label this as a nucleophile. Okay, so that is the why condensation polymers can be biodegradable, because they're hydrolyzed by water, like in the rain, and then therefore broken down into smaller molecules, whereas the addition polymers, like polystyrene and polyethylene, they're not broken down by water, they're not broken down by anything in the environment, and so they stick around pretty much forever. So let's consider the next row, the advantage of being inert. Right, so there is an advantage of being inert and therefore non-biodegradable, and that would be that, for example, the polystyrene cup that you might drink your tea or coffee with. It won't react with the water in the coffee. Okay, so that's an advantage of being inert, but of course there is a big disadvantage of being inert, is that they are non-biodegradable. Because the bonds can't be hydrolyzed. And that leaves us with the advantage of not being inert, which is they are biodegradable. And there we are. There's a comparison between addition and condensation polymers and an explanation of how they are either non-biodegradable in the case of addition polymers or biodegradable in the case of condensation polymers. So already we can see that we've ticked off our first two lesson objectives, because these are the addition polymers. Polystyrene, polyethylene, and polyesters and polyamides are our condensation polymers, and they can be broken down by hydrolysis, the addition of a water molecule, and therefore biodegradable, because the rain will provide the water, and you will degrade the polymer into back into small molecules like the original monomers. Okay, so we're going to move on to appreciating the advantages and disadvantages of disposal methods as per this learning objective here. So if we're talking about a disposal of this plastic, how much are we talking about? How much plastic do we have to dispose of? Well, in the UK we throw away 3 million tonnes of plastic every year, and that's quite a lot to dispose of. It's a massive, great big mountain of plastic if we were to put it all in a landfill site. So what do we do with all these plastic objects? Well, we have a flow chart that we're going to use. Here it is. We're going to start off on the left, as you see, with waste plastics, and we basically have three ways of disposing our plastics. 1, 2, and 3. Okay, and the first is we could bury it in the landfill. But people don't like that because it's ugly and it gives off fumes and all sorts of other reasons. So we need alternative strategies, because it's pretty ugly and it uses a lot of space and it's not even healthy. So we could actually burn it as a fuel. And we'll consider the advantages and disadvantages of burning it as a fuel, because it's not all bad. And thirdly, we could actually recycle it. And quite common in Germany and in many other parts of Europe, pretty much all of the plastic products are recycled. In the UK, we're catching up. 3/4 of our plastics are recycled now. And so this flowchart on the right is going to give us some detail about recycling process. So if we're going to recycle, the first thing we have to do is we have to sort the plastics, because some of it can be remolded straight away. For example, if your plastic is thermosoftening, then you can just heat it up and remold it into a new plastic. So you could remold it. in which case you can make new plastic objects. But if it's a thermoset plastic, you remember from GCSE, they're the plastics with crosslinks in them. They don't respond well to heat, they don't soften in heat, and so with those you're going to have to crack them. You're going to have to use the cracking process to split them into the small molecules, and once you've split them down by cracking into smaller molecules, then you can process them again in plastic processing plants, and you can make either new plastics or other chemicals. And that's what we do with all these plastic objects. We do either burying them in the landfill, we burn them as fuel, or we recycle them. And if we recycle them, first of all we have to sort them into type of plastic, and then you can deal with the plastics separately and eventually reuse them. So let's now go into a little bit more detail about this item here, burying them in landfill. So burying waste plastic is one way of disposing it, and it is relatively cheap and easy. But you can see this landfill site in the picture is it's not very attractive, and it also gives off some nasty fumes. So they would be disadvantages. But we do use landfill sites, and we use it when the plastic is difficult to separate from the other waste. Right? So if we've not done a very good job of our correct separation by in our recycling process, when we're leaving it out for the recycle men to come and pick up, then if it's difficult to separate, then it will end up eventually in a landfill site. And sometimes it's not in sufficient quantities to be financially viable. Right? So to recycle it, you have big recycling plants, and they need a lot of throughput to make them financially viable. And if there isn't enough throughput, then it's not commercially viable, and it won't happen. And some plastics are just technically too difficult to recycle. You know, if for some of the thermoset plastics, when you try and crack them into smaller molecules, you're just ruining the molecule, and you're not getting any raw materials that you can do anything else with. So it's just a bit technically difficult to do that for some of the thermoset plastics. So there are times when you landfill the plastics, but the disadvantages, as we've alluded to, are manifold. One of which is it requires land, and certainly where we live in London, land is at a premium, houses are expensive, and why should we use land to just put our old rubbish on? So it requires land, that's a disadvantage. Also, as waste decomposes, we get methane released, which is a greenhouse gas. It's a very potent greenhouse gas, much more potent than carbon dioxide, for example. And lastly, any leaks that are coming from this waste, they can contaminate water supplies. So this is just on ground, and the rain is going to wash any leaks eventually into the water system, which could possibly lead to contamination. So not nice either. So generally we try to minimize the amount of plastics that go into landfill sites. And the second way that we can dispose of plastics, you might remember from the first slide, was to actually burn it. So it can be burnt, and the heat can be used to generate electricity, which is useful. And here we have a furnace with burning plastic, and the heat would be usually generating steam, and the steam would turn a turbine, and the turbine would create electricity. And that has an advantage, obviously, but toxic gases can be released. For example, PVC, very common polymer, produces hydrogen chloride gas, which if you just let that go out of the exhaust chimneys, would create very acidic rain for us, which wouldn't be nice. So we would be obliged to remove that hydrogen chloride gas with a base, such as quicklime, for example, in a long chimney, that it can go past and be neutralized. However, even if you did that by burning anything, let alone plastics, you are still going to get carbon dioxide coming off, and that will contribute to the greenhouse effect. And obviously, if you're burning it, you're only recycling it once. Whereas, you know, if we recycle our plastics, you can do that any number of times. And a third method of our disposal was recycling. And a couple of points about recycling before we move on to our advantages and disadvantages of recycling are, firstly, that plastics are made from oil, and oil is non-renewable. It's running out. So recycling makes sense. And this little diagram here illustrates the fact that oil is running out, and when oil runs out, we won't be able to make any more plastics. So we better recycle what we've already made, because they are so useful, and they're very difficult to make out of anything else. So it's imperative to recycle plastics. And when we do, we can see on the bottom, next time you're drinking it from a plastic water bottle, have a look on the bottom and look at the symbol you can see. You will be able to see one of these symbols, probably the first one. And these are the recycling symbols that tell the sorters what sort of plastic it is. And depending on what sort of plastic it is, it leads them to recycle it in one way or another. And so you can see one is PET, that's the stuff that your drinks bottles are going to be made out of, for example. And you can see the other common plastics there as well. And that makes sorting easier. So now what we're going to do is we're going to move on to our advantages, which are clear, but also our disadvantages of recycling. Because there are disadvantages to recycling. Let's have a look. We're going to draw ourselves a table of advantages and disadvantages, because in an exam you can't just say cost, because actually cost is an advantage and a disadvantage. It could quite easily be a 4, 5, 6 mark question, in which case you're going to have to delve into some detail. So here is that detail for you. So the first advantage, let's do the easy ones. Let's do the advantages of recycling. So firstly, we can say that it reduces the amount of waste going into landfill. Because it's not just plastics that go into landfill. So smaller landfill mountains have got to be an advantage. But what's more, it saves raw materials. So these raw materials, i.e. the fractions from our crude oil, if we recycle it, we'll need less. So it saves raw materials. Which is important. As oil is non-renewable. And what's more, the cost of recycling plastics is lower than making the plastics from scratch. So this is the first cost. So cost of recycling plastics and that's particularly true when oil is expensive, as it has been in the last few years. And lastly, it produces less carbon dioxide emissions than burning the plastic. So if your alternative is burning them, then it's going to produce less carbon dioxide. So there we are. We have 4 advantages. They're the 4 main ones. But there are actually disadvantages, and one of which is that it is quite actually difficult to recycle plastics. And it's the sorting of the plastics. You have to sort the colours, you have to sort thermoset, particularly from thermosoftening. So it's quite difficult, quite technically difficult. To recycle plastics. What's more, collecting, sorting and processing the plastic is more expensive than either burning or landfilling it. So collecting, sorting, so although recycling is cheaper than making it from scratch, it's actually more expensive than just burning it or sticking it in a landfill. But here, of course, we're only dealing with the disposal and not the recreation of more plastic. That was number 2. And number 3 is actually you can't often make the plastic you started with. You know, so just because you're recycling the plastic doesn't mean you can make the same plastic again. You often have to make something difficult, so we can include that as a disadvantage. So you often can't remake the same plastic. And lastly, the plastic can be easily contaminated during the recycle process. So the plastic can be contaminated during the recycling process. There we have it. So we've got 4 advantages and 4 disadvantages that you'd do yourself a favour if you remembered. Good luck with that. And that's about it. One last point to make, and that's about supermarkets. And supermarkets have come under a lot of criticism over the years for creating so much plastic waste. When you unpack your weekly shop, then you'll see pretty much everything is packed in plastics, and some of the plastics can't even be recycled. You have to just put it in the bin. And so supermarkets responded by doing several things, and some supermarkets responded better than others, and in my personal opinion they haven't responded enough, but that's more down to us as consumers with our buying choices rather than the actual supermarket. Supermarkets will do anything to sell their products, and if they're going to sell their products to me, they need to be quite environmentally careful. Anyway, supermarkets have responded to some degree by reducing their packaging, by employing scientists to develop plastics that biodegrade quickly, and also by selling bags for life to encourage us to reuse those plastics. So here we have a picture of somebody bringing along a paper bag and dispensing some sort of product you buy, I don't know, what's that, nuts or seeds or something, from a dispenser. And so clearly you can see that there's going to be much less packaging there than you might get otherwise, and also it's made out of paper, which is more renewable than oil. So that's the reducing packaging point. Also, supermarkets employed scientists to develop biodegradable plastics. And here we've got a picture of a plastic bottle that's been left out in the rain, gradually biodegrading, so just disappearing. So if we're not going to recycle it and it is going to appear in a landfill site, we do want it to degrade. We don't want it to stay there forever. So if this plastic is biodegradable, then that's a good thing. And also we are sold bags for life, so that we could reuse them. So instead of just taking a polyethylene bag and getting your shopping home and sticking it straight in the bin, you can actually buy a bag that can be used over and over again. So there we have supermarkets doing something at least to help us take care of our scarce resources. Okay, that's it for disposal of plastics. What just remains for us to do is to look at the learning objectives. And here they are. Let's just make sure we've covered them all off. Polyalkenes, that's the additional polymers. They're inert, so non-biodegradable. We're going to remember that. Whereas condensation polymers, like polyesters and polyamides, they are biodegradable because their linking bonds are polar, which enables water to hydrolyze the polymers and break them down. So we did that. And we also appreciate that there are advantages and disadvantages to each method of disposal. So we can either burn it, we can put it in landfill, or we can recycle it. And lastly, we did look in some detail at the advantages and disadvantages, 4 of each, to the recycling of polymers. So we've done everything, and that's what you need to know about disposal of polymers. Thank you very much.